Good evening everyone, am I audible? Good evening all, am I audible? Yeah. Payush Sharma, good evening. Simultaneously. So using the web server, we are going to control the LED and using a push button through physically and through web server also. So let's see the introduction of this. Dinesh Kumar, are you asking about the Google form link? I think I already posted it in the chat box. So for your reference, if you want again also, I will give it. So here is our third assignment Google form link, make use of it. So now let's see the introduction part. So today we are going to see how to control the ESP8266 outputs using a web server and a physical button simultaneously. So the output state is updated on the web page, whether it is changed via physical button or web server. So now let's see the overview, actually how it works. So we are going to use an LED, physical button, web server and our microcontroller. So you can program in ESP32 or ESP8266. The code is compatible for both controllers. So you can use any microcontroller using the same code. Okay. So the ESP32 or ESP8266 hosts a web server that allows you to control the state of an output. So the current output state is displayed on the web server. The ESP is also connected to a physical button that controls the same output. So if you change the output state using the physical button, its current state is also updated on the web server. So if you are controlling this LED using this web server, in the sense you also get the notification, which means you can also see the differences here, like on, off. So also if you are physically control using physical button, in the sense, then also you can get the same changes over here. So here I define 32 and as well as for 8266. So if you can use 32 microcontroller or 8266 microcontroller, this code is compatible for both microcontrollers. So you can use the same code for the two microcontrollers, right? So if you are using 32 microcontroller, in the sense this library is used. Otherwise 8266, in the sense this library is used. So these lines are conditional includes based on the target platform. So if the code is being compiled for ESP32, it includes the Wi-Fi and asynchronous TCP libraries. Otherwise, it's being compiled for 8266. It includes the 8266 Wi-Fi and ESP asynchronous TCP library. So the ESP32 and ESP8266 are different microcontroller boards that require different libraries to work with Wi-Fi and asynchronous TCP communication. And coming to this library, so this line includes the ESP asynchronous web server library, so which provides an asynchronous web server implementation for ESP32 and ESP8266 boards. Then what? We have to initialize the network credentials. So this line defines the network credentials for connecting the ESP32 or ESP8266 to a Wi-Fi network. So the SSID variable represents the Wi-Fi network SSID, which is your Wi-Fi's name, and the password. And coming to this line, this line defines a constant variable called parameter input 1 with the value state. So it is used later in the code as a parameter name. So then I define button number and LED number as well. So this line defines two integer variable. Output represents the pin number D4 which an LED is connected, and button pin represents the pin number D2 to which button is connected. And then there are another variables like LED state, button state, and last button state. So these line declares integer variable used for managing the LED and button state. So it holds the current state of the LED, either low or high, and button state. And coming to this, so these line declare unsigned long variables which is used for debouncing the button. So the last debounce time stores the timestamp of the last button state change, and debounce delay, which is the syntax is a raw. So it creates an XML HTTP request object and sends a GET request to the server based on the checkbox state. So the response from the server is used to update the checkbox state and displays the output state as well. So there is also an interval function that executes every 1 second, which is 1000 millisecond. It sends an XML HTTP request to the server to retrieve the current state of the output. So based on the response, it updates the checkbox state and the output state displayed on the web page. And at last, so this line completes the HTML content and closes the raw string literal. So overall, the index HTML constant character array represents an HTML page that includes a title, CSS style, a heading, a placeholder for a button, and JavaScript code to handle checkbox changes and update the output state dynamically. So it is designed to be served by the ESP32 or ESP8266 web server to provide a user interface for controlling an output. Here we are using LED, right? And displaying a state. Now this line. So this code defines a function name processor that takes a string argument variable and returns a string value. So this function is used as a callback by the web server to process placeholders in the HTML content and replace them with dynamic value. And inside there is a condition, if condition. So if the variable argument is equal to the string button placeholder, the function proceeds with generating the HTML content for the button. So the inside then this line. So then it creates an empty string variable called button. Then it calls the output state function to get the current state of the output and stores it in the output state variable. And this. So these two lines. It creates an HTML h4 element with text and an empty span element with the ID attribute set to output state. So it also adds a label element with the class attribute set to switch. So inside the label there is an input element of type like checkbox. Here it is. Here. Checkbox with an on change even listener calling the toggle checkbox JavaScript function, which is when the checkbox state changes. So the ID attribute of the input element is set to output and the output state value is appended to the input element to set its initial state. So finally a span element with the class attribute set to the slider is added. And then it returns the string. The button string is then written. So if the variable argument is not equal to that button placeholder, an empty string is written, and then this string output. So this code defines another function called output state that returns a string value representing the state of the output pin. So inside there is a condition. So inside the function it uses the digital read function to read the state of the output pin. So if the pin is high, it returns the string checked, indicating that the checkbox should be checked. So otherwise it returns an empty string and then return. So in the end an additional return statement is redundant and unreachable. So it has no effect on the code execution. So overall, the processor function is used by the web server to process placeholders in the HTML content, specifically the button placeholder. So it generates the HTML code for a button, including the checkbox and its initial state, based on the current state of the output pin. So the output state function is called to determine the initial state of the checkbox. And then coming to void setup at first. So it initializes the serial communication with a baud rate of 115200, so which allows communication with the computer for debugging and logging purpose. And then these two lines. So it set the output pin as an output pin to control the external device, and it set the initial state of the output pin to low, and then this. So it set the button pin as an input pin to read the state of a button. And then we have to begin the SSID and password, which we have already provided, right? And then while loop for Wi-Fi check. So this code then proceeds connect to the Wi-Fi network using the provided SSID and password, and it waits until a connection is established. So before moving forward, so during this time it prints connecting to Wi-Fi to the serial monitor. Then what we have to do is that we have to print local IP address on the serial monitor. So finally it prints the local IP address assigned to the 32 or 8266 microcontroller board via Wi-Fi. And this lines. So this section configures a route on the web server for the root URL. So when a client sends a GET request to the root URL, the specified lambda function, which is the inside the function, is executed. So inside the function it sends the index HTML content as a response to the client. So the processor function is used to process any placeholders in the HTML content. And then up to this line. So here this section set up a route for update URL. When a client sends a GET request to this URL, the specified function is executed. So inside the function it checks if the request has a parameter named parameter input 1 here, which is a state indicates. So if the parameter exists, it retrieves the value using request get parameter. So value and store it in a input message variable. And then this lines. So this code then converts the input message to an integer using input message.to integer and set the state of the output pin accordingly using digital write, and it also toggles the LED state variable. So then else. So if the parameter does not exist, it sets input message and input parameter variable to default value. And then the input message is printed to the serial monitor and the server responds with an HTTP status code 200 and the plain text response OK. And then again, so this section set up the route for the state URL. So when a client sends a GET request to this URL, the specified function is executed. So inside the function, it reads the state of the output pin using digital read and convert it to a string using string and sends the response containing the pin status plain text. So finally server.begin start the web server. And then coming to this, so inside the loop function it continuously check the state of the button which is connected to the button pin and control the state of the output pin accordingly, and it reads the current state of the button pin and store it in the reading variable and this condition. So if the current reading is different from the last button state, it means the button state has changed. So in this case, the last debounce time is updated with the current time, which is millisecond function, and as well as this function. So this condition. So if the time passed, since the last debounce is greater than debounce delay, it proceeds to check if the current reading is different from the button state or not. So the reading is different, it means the button state has changed and stabilized. It updates the button state and toggles the LED variable. And at last, finally it sets the state of the output pin and updates the last button state with the current reading. So this is all about the code explanation. It is clear, everyone? Do you have any doubts regarding this? Is it clear? Is it clear, everyone? Drop your replies in the chat box, please. Is it clear? Okay, now let's see the hardware part. So here I have connected push button and LED with resistor. So the ground side of the LED has to be connected to the ground of ESP8266 and the positive side of the LED has to be connected with D2, which is GPIO2. Sorry, D4. Yeah, D4 is LED pin and D2 is push button pin. Yeah. So one end of the push button has to be connected with 3.3 volt and the same side of the resistor where we place the resistor, so same side has to be connected with the D2 pin and other end of the resistor has to be connected with ground pin. So this is all about the connection. So now let's upload the code into the microcontroller. Before that, make sure that you have selected the board and port. So let it upload. it's uploaded. So let me open the serial port now. So here the same baud rate. So it's connecting to Wi-Fi. So here it is our IP address. So now go to your browser and search for the IP address. So 192.168.2.122, right? Okay. So here is our web server. So the page look like this. This is our heading ESP web server and output GPIO 2. So our LED pin is GPIO 2, right? So now this state is off. So here you can see the output, right? Sorry. So here I on the LED. So here LED is on. So now I off this. LED is off. On, off. So same here. If I press the push button, the LED is blinking. So in the web page also you can see the changes, right? So off, on, off, on. As well as you can change through your web server also. So this is our output. So if you go to your serial monitor, in the sense here you will see 0101. So for on, off, on, off. Connection was loose, that's why the LED is just blinking. So here also you can see the difference. So this is our output. Is it clear, everyone? Is it clear? Everyone, is this clear? So tomorrow is the last day class, your 20th day. So tomorrow you will get your 4th assignment. And after tomorrow is the 20th day, so then you have time for 10 days for your you can make your own project by yourself, right? So actually this is 30 days class, so 20 days is your online class and 10 days it's time for your project. So you can do any project. You can do the same project which we are learned in the 20-day session. You can combine sensors, you can combine the like you can use cloud, web server, everything, and you can make your own project by yourself. So you have 10 days time, you can do whatever you want which you learn. There is no rule for you have to do this, you have to do that. You can do anything, but your project should based on IOT. So don't forget that. You can use 32 microcontroller, you can use 8266 microcontroller, whatever, whichever you have. But your project should be in IOT based. Remember that. But the project should be anything. You can do any project what you want, but it should be based on IOT. Then only your project will be valid. So do you guys have any queries or do you have any doubts? In the sense you can ask me regarding everything. If you have any doubts regarding the class, in the sense you can ask me. If you have any doubts regarding the entire class or something, in the sense you can ask me. Is it clear, everyone? Do you have any doubts or do you have any queries? So tomorrow is the last class. Yeah, okay, I will provide you the first and second assignment link also. So I will provide you the 3 link at once. Make use of it. So please try to submit all your assignments within tomorrow. So tomorrow is the last day. So if you submit after 20 days, it will not be valid. So that's why I am repeating again and again. Try to submit all your projects before tomorrow. But you have time for your 4th assignment, but you should submit all your assignments remaining 1, 2 and 3 third assignments, and 4th assignment you will have some times. Actually, our Facebook community and LinkedIn community in a private, I think I'll check once and I will inform you tomorrow. Okay, Venkateshwara? Abhishek, have you post actually the assignments in community, which means have you post your assignments in LinkedIn or Facebook itself? If link doesn't work in the sense, I will go and check your name. Where you post your assignment, in LinkedIn or Facebook? Actually, these 3 links are the links which I have already posted it in the chat box. There is no other link. I'll check your name in the group, Abhishek. I'll let you know tomorrow. Samuel, sorry for this. I will check it today. Once I accept your request, your post will be there. I will check it. So after 20th day, I will check all assignments, all of your assignments and your name, everything and all. I will note everything. I will accept and the remaining request also. So don't worry about that. If once you posted your assignment in the group, I will check. I think your request is not yet accepted, I think. I will check all your queries. Once you post it, in the sense, don't worry about that. I will approve all the assignments and I will accept all the requests. I will note. Yeah, okay. So, do you have any queries? Remaining members? So please do any project based on IOT. You have 10 days time. So just try to make any simple project or any mini project you can do. So first 2 days only there is a we have seen theory class, right? So remaining 18 days we have seen all the interfaces and all the topics. So using that you can make it your own project. So don't waste your time. Please do any mini project or any simple project based on IOT by your own. We will talk about the final project session in tomorrow's class, Samuel. Tomorrow I will explain everything about the final project and how you should do, where should you post the assignment and everything and all. I will tell you tomorrow. But today I also don't know clearly where should you post the assignments. I will consult with my seniors and I will convey the message to you tomorrow. If you don't have hardware with you, in the sense you can do simulations also, but it will be better if you do projects with hardware in the sense. So if you don't have hardware in the sense, just try with simulations. So is it clear? Shall we wind up the class? I will tell you the every details about the final project in tomorrow's class. So those who have submitted your assignment but still you can't view your post, in the sense still your request doesn't accept, in the sense, don't worry about that. I will do everything. So once if you post it, just let it be. I will notice everything. So don't worry about that. I will go and check it once, and I will explain the final project about tomorrow's class. So still, do you have any queries in the sense? You can ask me in tomorrow's class. I will explain. So this is all about today's session. Shall we wind up the class? So thank you all. Have a very nice day. We'll catch up at tomorrow's class with last topic.